Good afternoon, students. Welcome to the 28th lecture of refrigeration and air conditioning subject. Today is the last class for this week. Hope we'll complete the class within time. The today's topic of this class is classification of condensers, the factors affecting the condenser capacity, and various types of condensers. What we'll discuss in this class, right? Okay, we'll go ahead. Okay, so in the last class we have discussed about what is the meaning of a condenser, what is the principle of a condenser, how the condenser will work in a refrigeration system. Now we'll see what are the factors affecting the condenser capacity. So the factors that are affecting the condenser capacity. Let's see the factors. The condenser capacity is the ability of a condenser to transfer the heat from a hot vapor refrigerant to the condensing medium. Okay, so it is ability of a condenser to transfer the heat. Okay, the condenser to transfer the heat from what? From hot vapor refrigerant nunchi condensing medium. The heat transfer capacity of a condenser depends upon many factors. So what they are saying here, the condenser is to transfer the heat from the hot vapor refrigerant to the condensing medium. The factors are, first one is material. First one is a material. Since the different materials have different abilities, since the different materials are having different specifications and properties and abilities of heat transfer, therefore the size of a condenser of a given capacity, therefore the size of a condenser of a given capacity can be varied by selecting the right material. Okay, of a condenser of a given capacity can be varied by selecting the right material. It may be noted that higher the ability of a material to transfer the heat, the smaller will be the size of the condenser. So that's why, so if you take the small size of condenser, the higher the ability of a material. So if you take a bigger size of condenser, the slower the capacity of a condenser. So that is a first factor, that is about the material of a condenser. Next, a second factor is amount of contact, means how much contact we are making with the condenser. The condenser capacity may be varied by controlling the amount of contact. Okay, the condenser capacity may be varied by controlling the amount of condenser between the condenser surface and the condensing medium. Okay, contact between the condenser surface and condensing medium. This can be done only by varying the surface area of a condenser and the rate of flow of condensing medium over the condenser surface. The amount of liquid refrigerant level in the condenser also affects the amount of contact between the vapor refrigerant and the condensing medium. The portion of the condenser used for liquid subcooling cannot condense any vapor refrigerant. Means here the amount of contact, okay, how much amount of contact is based upon the amount of contact between the condenser and the condensing medium. Therefore, the amount of contact of condensing medium portion condenser for liquid cooling cannot condense any vapor refrigerant. Next one is temperature difference. Next factor is, first one is a material, second one is amount of contact, third one is a temperature difference. The heat transfer capacity of a condenser greatly depends upon the temperature difference. Okay, the heat capacity of a condenser greatly depends upon the temperature difference between the condensing medium and the vapor refrigerant. Condensing medium and the vapor refrigerant. So when the temperature increases, the heat transfer rate also increases and the condenser capacity increases. If the temperature cannot be controlled and the temperature differences become so great, then the devices are available that will be a problem. So that will make a change in the condensing surface of air flow rate to control the condenser capacity. Okay, so the amount of temperature difference between the condensing and vapor refrigerant should be adequate, right? So the temperature difference, if it is low, okay, the temperature difference if it is increases, then automatically the heat transfer also rate increases. If the heat transfer rate increases, then automatically the condenser capacity also increases. So this is the third factor of the factors affecting the condenser capacity. See the next point. Next one is classification of condensers. Got it? So the factors which are affecting the capacity of a conductor is, first one is a material, second one is a amount of contact, third one is temperature difference. Next, classification of condensers. So condensers of medium size, right? According to the condensing medium, what they are used, the condensers are classified in the following three groups. The first one is air cooled condensers, water cooled condensers, evaporative condensers, right? So coming to the classification, there are three types of condensers. First one is air cooled condensers, water cooled condensers, and evaporative condensers. So we will discuss those three in detail in the next slides. Next one is heat rejection factor. Next one is a heat rejection factor. So the vapor compression system, so we have discussed already in the unit 2, that is vapor compression refrigeration system. The heat is rejected in the conductor, right? So the heat is rejected in the condenser. So the load on the condenser per unit of refrigeration capacity is known as heat rejection factor. What is the meaning here? The load of a condenser, right? The load of a condenser per unit of refrigerant capacity is known as heat rejection factor. The load of a condenser QC is given by, so the load of a conductor QC is given by, QC is equals to refrigeration capacity plus work done by the compressor. Refrigeration capacity by plus work done by the compressor, that is equal to refrigeration capacity RE plus W. RE plus W is the refrigeration capacity plus work done by the compressor. So here the load on the condenser per unit refrigeration capacity will be formed based upon the nature of the condenser. So the load of a condenser QC is given by refrigeration capacity RC, refrigeration capacity plus work done by the compressor. Refrigeration capacity by work done by the compressor, that is equal to RE plus condenser, RE plus the work done by the compressor. So right, RE plus W, therefore heat rejection factor, because so again it is increased, that is 37.8. Now QC is equals to RE plus W. Therefore, the heat rejection factor HRF is equals to QC divided by RE. Therefore, what is the QC? Already we know that the QC, what we have discussed is QC is equal to RE plus W. Therefore, QC is equals to RE plus W. That is equals to RE. So, then ఇంకా further simplify చేస్తే 1 is equals to 1 by CRF. So QC by RE is equals to RE plus W divided by RE. Therefore, common తీసుకుంటే 1 plus W by RE, that is equals to 1 plus CO 1 plus 1 by COE. Therefore, QC, where is the QC? Yes, HRF, heat rejection factor, is equals to 1 plus W by RE. W by RE ante COP. Okay, RE by W means COP. Therefore, W by R is equals to 1 plus 1 by COP. From above, we see that heat rejection factor depends upon the coefficient of performance, which in turn depends upon the evaporator and condenser temperature. So, in actual air conditioning applications, for R12 and R22 refrigerants and operating of a condenser temperature, the evaporator temperature minus of 4 degrees centigrade, heat rejection on the air of about so from the above point, we see that the heat rejection factor depends upon the coefficient of performance, which in turn depends upon the evaporator and condenser temperature, right? So this is about the heat rejection factor. Next, the classification of condensers. So we have seen air-cooled condensers, water-cooled condensers, and man-made type of condenser, right? So now see here, air-cooled condensers. So we'll see the first point is air-cooled condenser, water-cooled condenser, and evaporative condensers. So among those three, we'll see step by step. First one, air-cooled condenser. So see the figure of the air-cooled condenser. It is a box-shaped SS metal shaped condenser where the fan is operated from a top side. So this is a exhaust fan which is rotating, and this is a evaporator setup. Now see this 2D air cooled condenser figure. So this is the inlet. So the inlet pipe, now see here, now see, so these are the fins as what we discovered in the evaporators. This is the tubing which is in a S-shaped tubing. So air cooled condenser is one which is the oldest, which is the removal of heat is done by air. So in the air cooled condenser, the condenser of air in the home is removed by the air. Okay. The air cooled condenser is one in which the removal of heat is done by the air. it consists of steel or copper tubing through which the refrigerant flows. Okay, it consists of steel or copper tubing through which the refrigerant అనేది flows. So what type of material we are using? So we are using steel. We are using steel gani, copper gani tubing. The size of a tube usually ranges from 6 mm to 18 mm outside diameter. Next, the depending upon the size of the condenser. So depend upon the specification of a condenser, the tubing general ranges from 6 mm to the 18 mm depending upon the size of a condenser. Generally, the copper tubes is used because of excellent heat transfer facility. So copper tubes, if you see it, the copper tubes are everywhere assembled where the air is done. So here the dissipation of heat, the air pressure is okay. Now see here, generally the copper tubes are used because of the excellent heat transfer ability. The condensers with steel tubes are also used for refrigeration systems where the ammonia is used as a refrigerant. Okay, the tubes are usually provided with the plate fins. Now see here, the condenser with the steel tubes are used in ammonia refrigerant systems. The tubes are usually provided with the plate type fins. Okay, the tubes are generally provided with the plate type fins to increase what? To increase the surface area of the heat transfer. The tubes are usually provided with the plate fins to increase the surface area of the heat transfer. Now the figure 10.2 shows the fins are usually made from aluminum because of lightweight and floor space. The fin spacing is quite wide to reduce the dust locking. Okay, so this is about the basic concept of a air cooled condenser. Next, the condensers with a single row of tubing provides the most efficient heat transfer. How the heat transfer will be done efficiently when the condensers are of single row type. So if the design is changed automatically, it will not fetch. This is because the air temperature rises as it passes through the each row of tubing. Got the point? The condensers are with a single row of tubing provides the most efficient heat transfer. This is because the air temperature అనేది ఏం చేస్తుందంటే the air temperature rises as it passes through each row of tubing. So more efficient because the air temperature rises it as it passes through the each row of tubing. So the temperature difference between the air and the vapor refrigerant decreases in each row of tubing, and therefore each row becomes less effective. So the single row condensers require more space. The single row condensers the single row condensers require more space than the multi-row condensers, right? So the single row condensers are usually used in small capacity refrigeration systems. So if you are using single row condensers, automatically the efficiency will be increased. Therefore, the single row condensers are generally used for which type? Are used for a small capacity refrigeration systems such as domestic refrigerators, freezers, water coolers, room air conditioners. That's why if you see your domestic refrigerator, household domestic refrigerator, the back side, you can see a single column, a single row of fins designed like this. So when the multi fins are arranged, then what happens? Thereby the efficiency reduces, and also the design will become complex. The air-cooled condensers may have two or more rows of tubing. Okay, na? The air cooled condensers have two or more rows of tubing, but the condensers with up to 6 rows of tubing are common. Some condensers have even 8 rows also. These are the only the design changes. However, more than the 8 rows of tubing are usually not efficient. So the number of count of the tubing is also very important. So if more than the eight number of if more than the 8 rows of tubing are usually not efficient. This is because the air temperature will be too close to the condenser temperature to absorb any more heat after passing through the 8 rows of tubing, right? So in this way, the air cooled condensers are getting cooled to the refrigeration system. One thing is that the design changes. The second thing is the material changes. Third one is the miscommunication things. So that's why some of the disasters also will happen. So if the design or any problem occurs at the backside of the fridge, do something, right? So this is about the air cooled condenser. Air cooled condenser. Next, what are the types of air cooled condensers? Okay, na? What are the types of air cooled condensers? There are various types of air cooled condensers, right? The first one is natural convection air cooled condensers. Second one is forced conduction air cooled condenser. So what is the first one? Natural convection air cooled condensers. Second one is forced convection air cooled condensers. In natural convection air cooled condensers, the heat transfer from the condenser coils to the air is by natural convection. So natural mode of process will be happen at the natural air cooled condensers. As the air comes in contact with the warm condenser tubes. Okay, what happens here exactly? When the air from the atmospheric air comes in contact with the warm condenser tubes, it absorbs the heat from the refrigerant. It absorbs the heat from the refrigerant, and thus the temperature of the air increases, and thus the temperature of the air increases, and thus the temperature of the air increases. The warm air being lighter rises up, and the cooled air with the below rises to take away the heat from the condenser. So whenever the atmospheric air comes in contact with the condenser, what happens? The condenser tubes will become slowly normal. So it absorbs the heat from the refrigerant, and thus the temperature of the air increases. Therefore, the warm air being lighter than the cold air rises up, and cold air from the below rises it to take away from the heat from the condenser. So in this way, condenser లో నుంచి heat అనేది బయటికి వెళ్ళిపోతుంది. How? The warm air being lighter, it rises up, and the cold air from the below rises to take away the heat from the condenser. This cycle continues in natural convection air cooled condenser. Since the rate of heat transfer in natural convection condenser is slower, therefore they require larger surface area as compared to the forced convection condensers. The natural convection air cooled condensers are usually used only in small capacity applications such as domestic refrigerator freezers, water coolers, and room air conditioners. So that is about the natural convection air cooled condenser, right? Next, coming to the second point, forced convection air cooled condenser. Forced convection air cooled condenser. So in this forced type, again you are having two types of forced type convection. One is base mounted air cooled condensers, remote air cooled condensers. So in the forced convection air cooled condensers, the fan, so the fan means either the propeller or centrifugal fan, is used to force the air over the condenser coils. So natural కి forced కి difference ఏంటంటే, natural means the air naturally floats on the condenser tube, whereas in the forced type, so because of the design changes or any the manpower or maybe any problem, then what happens, we use artificial air generation, that is by centrifugal fan or centrifugal fan or propeller is used to force the air over the condenser coil to increase the heat transfer capacity. The forced convection condensers may be divided into two types. One is base mounted air cooled, next one is a remote air cooled condenser. So we'll see about the base mounted air cooled condenser. So they use propeller fans. They use propeller fans that are mounted on the same base of a compressor, motor, receiver, and other controls. So whatever the compressor, motor, receiver, and other controls are on the same base, the propeller fans are also designed on the same base. Next, the entire arrangement is called as condensing unit. Okay. See here. First one is a base mounted air cooled condensers. They use a propeller fans and mounted on the same base of the other components. The entire arrangement is called as a condensing unit. So in case of small units, the compressor is a belt driven type from the motor, and the fan required to force the air through the condenser is mounted on the shaft of the motor. The use of this type of compressor for indoor units is limited to 3 kilowatts capacity motor only. The refrigerant will be evacuated until the, see here. The use of this type of compressor for indoor units is limited to 3 kilowatts capacity. These condensing units are used on packaged refrigeration systems of 10 tons or less. 10 tons or less. Second one, the remote air cooled condenser. The remote air cooled condenser. So here they use on the systems about 10 tons and are available up to the 125 tons. The system above 125 tons usually have two or more condensers. These condensers may be horizontal or vertically designed. They can be located either outside of the building or inside of the building. Next one. The water cooled condenser. So here in the water cooled condenser, only the design changes is we are providing a spacing for water jackets to move inside the condenser coil. Condenser coil, right? So see the figure of the water cooled condenser. First one is the water cooled condenser is one of the condenser in which the water is used as a medium, condensing medium. So initial case lo air is used as a condensing medium. Here we are using water is not used as a condenser medium. They are always preferred when an adequate supply of clear inexpensive water and means of water disposable area available. So many of the people say that it is preferable when an adequate supply of clear and inexpensive water and means of water disposal are available. Those condensers are commonly used in commercial and industrial refrigerators. Right. సో ఇక్కడ ఏం జరుగుతుంది ఇక్కడ, This uh, so the water cooled condensers, we are using water as a separate medium. That's why the design may be some changes happens to the design. So here the water is used as a condensing medium. They are always preferred when an adequate supply of clear inexpensive water is used. These condensers are commonly used in commercial and industrial refrigerating systems. So these condensers are used in commercial as well as industrial applications. The water cooled condensers are again divided into two water systems. First one is wastewater system. Second one is a recirculated water system. So first one is called wastewater system. Second one is a recirculated water system. So see the figure here. The water cooled condenser using the wastewater system. Here the water cooled condenser with recirculating water system. So okay, the first one is a wastewater system, the second one is a recirculating wastewater system. Next, if you see the figure of the vapor water cooled condenser using the wastewater system. So see here where the water is coming. So where the vapor represent. So the vapor refrigerant from the evaporator. So from the evaporator place, the vapor refrigerant is passing to the compressor mode. And from the compressor it is passing to the right. So here from the evaporator, the vapor refrigerant is passing through the compressor, and from the compressor it is passing to the hot vapor. It is converted as a hot vapor vaporizer, hot vapor refrigerant. From there it is passing to the waste to cooled condenser. So where you are having the fins inside it and liquid detergent, liquid refrigerant is to receiver. So here the water is going up, the water is coming down. So if you see the water cooled condenser with recirculating water system, so here wastewater and water. So the water cooled condenser, so here you are arranging in a platform. This will be of big size, right? Now see the vapor refrigerant from evaporator is passing to the again compressor. So whenever there is a critical chance, the water cooled condenser with recirculating water. So here the only extra thing from here to here is, so that's why yeah. Got it. So at this point what happens, so in this case slight changes happens from the above figure to the this figure. So here the liquid represent to the receiver, the liquid represent to the receiver. So the urine is flowing from one end, or the urine is flowing from the right. Here you are having a cooling tower where the water is located, and you are having the valve here, make a water valve. So and you are having a connection. So we'll stop the class here. In the tomorrow's class, we'll discuss about the types of water cooled condensers. Okay, the types of water cooled condensers and the other comparison works. Okay, so we'll stop the class. We'll continue the class in the next, that is on Monday's class. Okay, that is on the Monday class or tomorrow's class also. No issues. The hot water refrigerant and the cooling tower make up water and condenser with water pump. Okay, here the hot water is going from this point, okay, and is passing into the cooling tower, passing into the cooling tower. From the cooling tower, the water is going into the cooling water in inside here, and it is maintaining with the condenser pump as well as a makeup water. So that is about the wastewater condenser with reciprocating, recirculating